All right, let's go ahead and talk about the problem of the day. Remember to compare your work to what we talk about together and answer the questions that I ask out loud. If you want to adjust or improve your work as we talk, that is great. You should definitely go for it. So there's a lot of ways you might have represented this problem. One way that I bet a lot of you used was to write a labeled number sentence. You had 4 chapters times 325 pages in each chapter, and that will give you the product of the total pages. There's also a lot of ways that you might have used what you already know to solve this. I imagine a lot of you used a place value array that looks like this, right? Where you went ahead and just like yesterday, you put 4 rows with 325 in each of those 4 rows and found your partial products. I don't show it here, but I imagine you added those partial products in order to find your final product, which makes sense. So this would work. Nothing wrong with this. But today we're going to talk about another more efficient strategy called the area model. The area model is a tool that we use to solve multiplication and division problems using the area of a rectangle and numbers in expanded form. So what do you think we're going to need to draw first as we start off this area model? Go ahead and say it out loud. Yeah, a rectangle. Great. And what do you think the side lengths will be for this rectangle? Why? Say it out loud. Right, 4 and 325. Just like when we set up our array of place value blocks. And 4 and 325, those total us our side lengths there as well. Right, they were telling us the rows and the amount in each row. Okay, so then what will the area of this rectangle eventually tell us and why? Go ahead and say it out loud. Yeah, the area of the rectangle is going to be the product of 4 and 325 because the area, right, is the length times the width. All right, we probably can't do 4 times 325 in our head. So how could we take advantage of place value and partial products in order to find the area of our rectangle? Think about what we did with our place value array up here. Go ahead and say out loud what you think we should do to get started finding the area of this rectangle. Yeah, we could write 320 and 5 in expanded form. And we could use these place values to actually divide our rectangle into 3 smaller rectangles. We find the area of each of these and add our partial products, just like we did up here with our place value array. So what's the width going to be of each of these 3 rectangles that we divided our larger rectangle into? And why? Say it out loud. Yeah, the width is going to be 4 because that's the other factor here that we're multiplying. So how did we find the area of this first rectangle? Why? Say it out loud. Right, we're going to take 4 times 300 because this rectangle has a length of 300 and a width of 4. 4 times 300 is 1200s or 1,200. Awesome. What about this rectangle? Go ahead and say it out loud. Yeah, 4 times 20. It has a width of 4 and a length of 20. 4 times 20 is 4 times 2 tens, which is 8 tens, or 80. Last one. How about that rectangle? Say it out loud. Yeah, 4 times 5, and that's 20. Okay, are we done yet? Why or why not? Say it out loud. Yeah, we're not done. We have to add each of our partial products in order to find the total area of the rectangle. So we have 1,200 plus 80 plus 20. That gives us 1,300. And note that the partial products that we got from our area model are the exact same as the partial products we got from our place value array. Cool. Okay, so last question here. How is the area model that we just did the same as the place value array? Go ahead and say it out loud. Right, in both cases, we're still finding the partial products of each place value of the larger factor. The math here is the same. We're just showing it now with an area of a rectangle instead of an array made of place value blocks. Cool. Go ahead and click on the arrow to move to the next slide.